Heating of copper can be represented as copper plus oxygen gives copper oxide. This simple form of representing reactions in words is called as a word equation. We can make this word equation more precise and concise by using the chemical formulae. We can represent heating of copper as Cu plus O2 gives CuO. The representation of a chemical reaction with the help of chemical formulae is called a chemical equation. Let us understand how to write a chemical equation. Writing a chemical equation. When copper is heated, it reacts with oxygen in air to form copper oxide. In this reaction, copper and oxygen undergo a change and hence are called as reactants. The new substance copper oxide so formed in the reaction is called as the product. The reactants are written on the left-hand side and the products are on the right-hand side of the equation. An arrow pointing towards the products is inserted between the reactants and the products. It also represents the direction of the reaction. A plus sign is inserted between two or more reactants or products formed. If reactions are carried out under specific conditions of temperature, pressure, using a catalyst, etc., then these conditions are mentioned on the arrow. In the heating of copper, the word heat is mentioned above the arrow to indicate the process of heating required for the reaction to take place. The chemical equation can be made more informative by mentioning the physical states of the reactants and the products. Copper is in the solid state, hence the letter S in brackets is mentioned. Oxygen is in a gaseous state, hence the letter G in brackets is mentioned near the formula. Copper oxide again is in a solid state, so the letter S in brackets is mentioned near the formula. If one of the reactants or the products is in the liquid state, then the letter L is mentioned in brackets near the formula. If one of the reactants or the products is a solution in water, then the letters AQ are mentioned in brackets near the formula. AQ stands for aqueous. For example, while representing the reaction between potassium nitrate and water to form potassium nitrate solution, the letter S is mentioned near the formula of potassium nitrate. The letter L is mentioned near the formula of water, and the letters AQ are mentioned near the formula showing solution of potassium nitrate. Consider some chemical reactions. Let us see how we can make the chemical equations of these reactions more informative. Reaction 1. Edible oil reacts with hydrogen gas to form fats. We shall mention the letter L near the word edible oil as it is a liquid. Hydrogen being a gas, we shall mention the letter G in brackets near the word hydrogen. Fats are in the solid state, so we shall mention the letter S in brackets near the word fats. The specific conditions of the reaction can be indicated by mentioning the word heat and the symbol of nickel, Ni, above the arrow. Reaction 2. Zinc metal reacts with a solution of hydrochloric acid to form zinc chloride with the evolution of hydrogen gas. Zinc is in the solid state, so we mention the letter S near the formula of zinc. Hydrochloric acid and zinc chloride are solutions, so we mention the letters AQ near their formulae. Hydrogen is a gas that is evolved, so we mention the letter G near the formula of hydrogen. Now, let us again consider the chemical equation of heating copper. Cu plus O2 gives CuO. Count the number of atoms of each element on both the reactant side and the product side. Enter these values in the table. There is one copper atom each on the reactant side and the product side. But there are two oxygen atoms on the reactant side and only one on the product side. Are the number of atoms equal on both sides? No, they are not. Such an equation is called a skeletal equation. Equations which represent a chemical reaction but are unbalanced are called skeletal equations. Balancing the chemical equation. Let us recall the law of conservation of mass. It states that matter cannot be created or destroyed during a chemical reaction. In other words, the total mass of the reactants is equal to the total mass of the products, or the number of atoms of each element before the reaction and after the reaction is equal. A chemical reaction cannot have unequal masses. Therefore, a chemical equation cannot be unbalanced. It has to be balanced. Balanced equations. Let us recall the equation in the experiment of ferrous sulfide and dilute sulfuric acid. Ferrous sulfide plus dilute sulfuric acid gives ferrous sulfate plus hydrogen sulfide gas. Is this equation balanced? Let us check this out by counting the number of atoms of each element on the left-hand side and the right-hand side. Enter the values in the table. There is one atom of iron on the left-hand side and the right-hand side of the equation. There are two atoms of sulfur on the right-hand side and the left-hand side. There are 2 hydrogen atoms on the left-hand side and the right-hand side. And there are 4 oxygen atoms on the left-hand side and the right-hand side. The number of atoms of each element on the left-hand side is equal to the number of atoms of each element on the right-hand side. Hence, this equation is balanced. Now let us understand the steps involved in balancing an unbalanced chemical equation. Steps involved in balancing a chemical equation. Consider the reaction between sulfur dioxide and hydrogen sulfide. Step 1. First, write the chemical equation for the reaction. SO2 plus H2S gives S plus H2O. Step 2. Compare the number of atoms of each element on both the sides of the equation. Let us enter these values in the table. There are 2 sulfur atoms on the left-hand side and 1 on the right-hand side. There are 2 hydrogen atoms on the left-hand side and 2 on the right-hand side. There are 2 oxygen atoms on the left-hand side and 1 on the right-hand side. Step 3. Choose a reactant or a product that has the maximum number of atoms in it. In this equation, we shall select SO2, that is, sulfur dioxide, and the element oxygen in it. We have seen that there are 2 oxygen atoms in SO2 in the reactant side and 1 oxygen atom in H2O, which is in the product side. Try and balance the number of oxygen atoms. To balance the number of oxygen atoms, we cannot make H2O to H2O2. In other words, we cannot change the formulae of a reactant or a product to balance a particular element. But we can change the coefficient of the deficient side, whether it is in the reactant side or the product side. We can put the proper coefficient 2 for the H2O molecule to balance the oxygen atom to get 2H2O. The equation can be expressed as SO2 plus H2S gives S plus 2H2O. Enter these values in the table. There are 2 hydrogen atoms in the reactant side and 4 hydrogen atoms on the product side. And there are 2 oxygen atoms on either side of the equation. Now the equation is partly balanced. Step 4. Select any other atom that is not balanced. In this equation, the S and H atoms are still not balanced. Let us select hydrogen atoms first for balancing. Try and equalize the number of hydrogen atoms as we have done earlier using coefficients. There are 2 hydrogen atoms in the reactant side and 4 hydrogen atoms on the product side. The deficient side is therefore H2S. Put the coefficient 2 for H2S molecule in the reactant side to balance the hydrogen atoms. Now, the equation can be represented as SO2 plus 2H2S gives S plus 2H2O. There are 4 hydrogen atoms on either side of the equation. There are 3 atoms of sulfur on the reactant side and 1 on the product side. Step 5. Now, select sulfur atoms for balancing. There are 3 atoms of sulfur on the reactant side and 1 on the product side. To balance the number of atoms, put the coefficient 3 for the S atom in the product side. The equation can be represented as SO2 plus 2H2S gives 3S plus 2H2O. Step 6. Now, let us count the number of atoms of each element in the equation. There are 3 sulfur atoms on either side of the equation. There are 4 hydrogen atoms on either side of the equation. And there are 2 oxygen atoms on either side of the equation. This is now a balanced equation. This equation can be made more informative by indicating the physical states of the reactants and the products. Sulfur dioxide and hydrogen sulfide are gases, so mention the letter G near the formulae. Sulfur is in a solid state, so mention the letter S near the formula. Water formed during the reaction is in the liquid state, so mention the letter L near the formula. Let us consider some more reactions. Reaction 1. Barium chloride plus sulfuric acid gives barium sulfate and hydrogen chloride. Is this equation balanced? Let us check this out by counting the number of atoms of each element on the reactant side and the product side. Let us enter these values in the table. There is 1 barium atom on the left-hand side or the reactant side as well as on the right-hand side or the product side. There are 2 chlorine atoms on the left-hand side and 1 on the right-hand side. There are 2 hydrogen atoms on the left-hand side and 1 on the right-hand side. There is 1 sulfur atom on either side of the equation. There are 4 oxygen atoms on the left-hand side as well as the right-hand side. The equation is not balanced. Which reactant or product has the maximum number of atoms in it? Sulfuric acid, H2SO4, has the maximum number of atoms. Let us first balance the hydrogen atoms. We know that the number of hydrogen atoms is not equal on the left-hand side and the right-hand side. Put coefficient 2 for the HCl molecule to balance the hydrogen atoms. The equation can now be represented as BaCl2 plus H2SO4 gives BaSO4 plus 2HCl. Enter this value in the table. There are 2 hydrogen atoms on either side of the equation. Are the chlorine atoms also balanced? Yes, there are 2 chlorine atoms on either side of the equation. The number of atoms of each element on the left-hand side is equal to the number of atoms of each element on the right-hand side. Hence, this equation is balanced. Reaction 2. Recall the chemical equation in the experiment of heating of copper. The equation was Cu plus O2 gives CuO. Is this a balanced equation? Let us check this out by counting the number of atoms of each element on the reactant side and the product side. Let us enter these values in the table. The number of copper atoms on the left-hand side and the right-hand side are equal. There are 2 oxygen atoms on the left-hand side and 1 on the right-hand side. The equation is not balanced. If we put a coefficient 2 for the copper oxide molecule, the number of oxygen atoms are balanced, but not the number of copper atoms. Put a coefficient 2 for the Cu atoms on the left-hand side. There are 2 copper atoms and 2 oxygen atoms on either side of the equation. The number of atoms of each element on the left-hand side is equal to the number of atoms of each element on the right-hand side. Hence, this equation is balanced. Reaction 3. C12H22O11 reacts with water to give 2 molecules of C6H12O6. What does this reaction describe? This chemical equation describes the reaction of sucrose with water in the presence of concentrated hydrochloric acid at a temperature of 323 Kelvin to form glucose and fructose. Name the reactants and the products. Sucrose and water are the reactants and glucose and fructose are the products. Let us now discuss the different types of chemical reactions.